I am Dr. Radhika. Today in this section we are going to be discuss about the different softening technique of water. Generally we have to be take that hard water when we take in the boiler for the generation of the steam, different problems are existed that we are considered as the boiler troubles. To remove all of these boiler troubles, we'll go for that different types of the softening techniques. One of the method in that is the zeolite technique. For this session, the presentations are here. We are going to be take it as the first one is what is hardness and softening technique for the removal of the hardness methods. In this softening technique, external treatment methods and internal treatment methods. We are concentrating in this the external treatment methods. One of the external treatment method is the zeolite technique. Water, here the hardness is caused due to the presence of the dissolved salts in water, primarily calcium and magnesium ions of a carbonate, bicarbonate, chlorides, sulfates and nitrates. It causes the formation of the boiler scales. When it is observed that the scale in the PVC pipeline, what are the problem of that the pipeline for the generation of the steam or in the normal way of the way the hard water we are using in the domestic appliance. The hardness generally we are considered the exact definition is the hardness of the water is considered as the hardness means hard water. Water which will not give the lather with the soap is considered as the hard water. Generally here this hardness is get that by the dissolved salts. So that here the water, this type of the water when it is used for the soap, instead of giving that the lather, here it will be produced as a white scum precipitate because to reacting the calcium and magnesium ions of the sodium stearates produces a white precipitate. So instead of getting the lather with the soap, here it is produces a white precipitate. Now how can we form that hardness? First of all, here the water where the water scarcity is more lagging problem. That means underground water where it is less, in that cases more dissolved salts are present. So that one here generally we can be see this diagram here how the top soil that is nothing but the fertile soil, and here the water when it is percolates into the lower level that the dissolved salts it can be here deposited in the lower layer the deeper level of the groundwater. So these groundwater when we take in the bore wells or well water, this type of the problem is existed more. So here we are going to be taking that the generally calcium carbonate, magnesium carbonate forms are here in the form of the insoluble states. But when it is reacting with the carbonic acid while reacting that the carbon dioxide water, it can be produces that the calcium bicarbonate. Generally the calcium bicarbonate and the magnesium bicarbonates are here soluble state in the water. It can cause more problem compared to that carbonates because the carbonates are in the form of the indissolved state in the water. So now here the hardness can be divided into two parts. Here one is the carbonate hardness and another one is non-carbonate hardness. Hardness which can be caused by the carbonates and bicarbonates of calcium magnesium is considered as the carbonate hardness. It can also be known as the temporary hardness of water. Non-carbonate hardness means here in the presence of the calcium magnesium ions of chlorides, sulfates and nitrates which cannot be removed by the boiling and the filtration, so that it can also be known as the permanent hardness, and it is not having the carbonates and the bicarbonates means this is also known as the non-carbonate hardness. Generally water hardness of the water we are considered as here it can be caused by the calcium magnesium ions of these ions anions of the bicarbonate, chloride, sulfates and nitrates. So how can we determine it? Yeah, generally it can be determined by the soap titration method, Clerk's method, Blacher's method, And here the normal laboratory what you have according to your syllabus, you have that the EDTA determination method by using the iriochrome black tea indicator. So that is also known as the complexometric method, because the metal what it is present in the water can react with the EDTA and produces a calcium EDTA complex. This is identified by the EBT, iriochrome black tea indicator color change from wine red to blue color. Next one, here the hardness units are, here it can be exhibited in the form of the milligram per liter, here the parts per million. And next one is here the degree clerk, degree French and milligram. It means the relation between all these is 1 milligram per liter is equal to 1 ppm, and that is equal to 0.1 degree French, and that one is here we are considering in the different equations. Now here we have to be take it as the scale of the general water. Here based upon that the quantity of the hardness in the water can be divided into different ways. Here that is, if the hardness if it is less than 15 ppm, ppm is nothing but part per million, that is 1 part of calcium carbonate in 10 to the power of 6 parts of water. We are exist, that means the hardness we can be determined in the form of the calcium carbonate equivalents. So all hardness causing salts are converted into the calcium carbonate and consider it as a 1 part of calcium carbonate in 10 to the power of 6 parts of water. Based upon that only here less than 15 if it is there, that is very soft water, and if it is 15 to 50, that we are considered as a soft water. 50 to 100 ppm medium water, and 100 to 200 generally it is hard water. If it is more than 200 and very hard water, it cannot be used for the domestic and as well as the industrial usage. So here we have to be considered that when the problem is there for that the hard water in the industrial and the domestic usage, wastage of the soap can be takes place. When it is used, this is in the industrial purpose, here the scale, sludge, corrosion can be takes place. The caustic embrittlement can also be caused by dissolving salts of these ions. So now here the softening technique is the alarming now for that the hard water means the hardness from the water can be removed by the different techniques. Here that one is the removal of these ions from the water is nothing but the softening techniques. So that one here either it can be by the precipitation method or maybe the ion exchange process. Here the precipitation of the calcium and magnesium by the added lime, soda, calcium type of the salts is one technique. This is the oldest technique. With this the number of the scum can be produces with the environmental pollution can be exhibited. So that generally we will use that ion exchange of the calcium magnesium with that the ions such as a sodium, or we can also be go for that all other anions can also be here exchanged with that the hydroxide ions and cations like a calcium magnesium with the H plus ion, that is hydronium ion. So this is the ion exchange process. It is compared to the precipitation methods, this is well and good. So now we are considering as under the softening techniques external treatment method and the internal treatment. External treatment means the water before going to take the usage in the boiler, generally we will treat it and then send it into that the boiler. And internal treatment filtration is means after taking the water in the boiler, generally we have to add some of the salts and then get it into the precipitate and remove those type of the salts in the form of the precipitate. So we have to be prefer that generally external treatment methods. In this external treatment also we have lime soda process, geolite process, ion exchange process. Now today's topic in this session is geolite technique to removal of the hardness in the water. Geolite is here the microporous material which can be here have it as the general formula sodium oxide, then alumina, silica, and then water. This is again here two types. One is the natural zeolite and then artificial zeolite. Here the natural zeolites are two types. Here it is means the naturalite is the best example under that. And next one, the zeolites are characteristically it is soft and moderately hard, and it can be easily removed at the exchanging of the sodium with the calcium and magnesium ions. The process when it is goes to that, the process is here we can be exchanging that the calcium and magnesium ions while passing through this. Here when we observe this diagram, no, here the raw water when it is passing from this the wire, here the water first it can be passed on that the pre-filter. Why we are taking the pre-filter means if it is having any solid particle, permanently it will be stick over in the zeolite bed. So that's why generally we can be remove that any solid particles, the dust. And here this one, the water when it is passed through this, the ions can be exchanged. This is the schematic diagram, and this one is here the general commercial zeolite process filter. And here when we take that the chemical reactions when we are considered, when the water containing of the calcium bicarbonate when it is passed, it can be converted into the calcium zeolite, and next one is the sodium bicarbonate is produced, and here it is magnesium bicarbonate same, and then here the calcium sulfate can be converted into the sodium sulfate, and next one is here it can be take it as the sodium chlorides. When you observe that here all that the water which is comes from that after filtration, water is containing of the number of sodium salts, and after taking the process here will means the bed can be completely exhausted, so that now it is go for that the regeneration technique by using of 10% of the brain solution or the sodium chloride solution. So it is 100% of that it can be removed, and then here these are the chemical reactions here, and means the sodium calcium zeolite, the magnesium zeolite, what it is present in the bed can be exchanged with the sodium reversely, and what the produced calcium chloride, magnesium chloride will be here transferred. So based upon this session now, here we will compare that the assignment based upon this. So we can be compare with the other methods, and here we can go for that how much hardness is there in the water can also be determined by this zeolite process technique. So this one here we are going to be take it as in the assignment part in the class. And here the merits, here this is remove that up to 10 ppm, and it can be automatically adjusted when the hard water is changed. And here it is it is not a precipitation means here it is a safe method. Disadvantage is only one thing, here only the sodium ions is existed still after completing that. If it is high turbidity, it cannot be useful. So in this here I concluded that here based upon this session you have to be prepared, read that one completely and prepare to that next class for that assignments. Okay ma, thank you.